So today we're going to look at lesson 5-7. It's one of my most favorite lessons of the entire course. I absolutely love Pascal's triangle, and I love using it along with the binomial theorem. And so what you're going to learn today is how to take a binomial, which is a two-term polynomial. Well, it's two terms and it's raised to a power. So it should look like something like this. A minus B raised to some power, I'll call it C. So there's your binomial right here, and we're going to raise it to this power. So we've talked about taking a binomial and raising it to the second power. And I've also shown you how to take a binomial and raise it to the third power, that there's a pattern for that. Well, after we have the third power, fourth and above, I like to use Pascal's triangle. This is Pascal's triangle if you've never seen it before. There was a very ancient mathematical philosopher, I don't know why I can't say that word today, Pascal. And he developed this triangle, and it's just a whole bunch of patterns and mysteries. It's really phenomenal. You can have an entire course just on Pascal's triangle. And what you'll notice about Pascal's triangle is that the first and the last number are always 1. And then it goes by rows. And you'll see some patterns along here. So if you look at this row here, 1, 2, 3, 4, 5, 6, 7, 8, and it goes in the other direction as well. And you'll see a whole bunch of other patterns all throughout here. The biggest pattern that I want you to realize is, number one, you don't have to memorize Pascal's triangle if you know how to derive it. So if you look at the first row is always 1 because we start and end with 1. The second row is going to have two terms, row 2, second row. Actually, this is the 0th row, but we'll get to that in a minute. But this next row starts and ends with 1. And then we start and end with 1 again. But how do we get this 2? So we always look at what comes above it. So above this 2 is a 1 and a 1. So 1 plus 1 is 2. To get the next row, start with 1. Add the 1 and the 2, we get 3. Add the 2 and the 1, you get 3, and end with 1. Then for the next row, start with 1. Go above it, add 1 and 3, you get 4. Add 3 and 3, you get 6. 3 and 1, you get 4, and 1, and so forth. So I'll just do one more. So to get this row, 1 and 4 adds to give you 5, 4 and 6, 10, 6 and 4, 10, 4 and 1, 5. And you will know that this is also symmetrical. I could draw a line straight down the center, and you'll see that some rows have a very center term that's unique. Like for instance, this row right here, this is the only 6 in the row. But to the left, you have a 1 and a 4, and to the right, you have a 1 and a 4. Whereas on this row, there is not any unique middle number. You've got two 10s. So if I split it in half here, it's symmetrical. You've got 1, 5, 10, and then 10, 5, 1. So the binomial theorem is right here, and it just looks like a bunch of gobbledygook, to be honest. It's basically giving you the pattern within here of the Pascal's triangle. I never, ever, ever memorized this. I just use Pascal's triangle. So let's go ahead and name our rows. So this first row right here, and a fascinating thing occurs with this, at least in my nerdy math brain, it's fascinating. So if you call this row the 0th row, you're going to notice something about the sum of all these rows. So if I add this number up here, I get 1. And if I add these two numbers here, I get 2. And if I add these numbers here, I get 4. This is going to become important in a minute. And if I add these numbers here, I get 8. And these numbers here, I get, 10, 15, 16. And these numbers here, I get 20, 32. And then these numbers here, I get 20, and then another 30 is 50, 62, 64. You should start to see a pattern here. If I add all these numbers together here, I get 128, I am just a math genius calculator. I'm actually using the pattern. And then if I add all of these up, I am going to get 256. So look at these numbers. They should have a pattern to them, and it matches the row numbers. So this is the 0th row, the 1st row, the 2nd row, the 3rd row, the 4th row, the 5th row. So you know the row number by looking at the second number. Well, this one doesn't have a second number. Its second number would be 0. This one's second number is 1, 2, 3, 4, 5. So this represents the row number. So if this is the, well, let's see. So this is the 0th row. What if I said that that represented 2 to the 0? Isn't anything to the 0 power 1? So 2 to the 0 is 1. And then for the next one, I said it was the 1st row. So notice that this 2 would represent 2 to the 1st. The next row I said was the 3rd row. I'm sorry, sorry, let me backtrack on that. This is the 0th row, 1st row, this is our 2nd row. And so for our 2nd row, 4 is represented by 2 squared. 8 is 2 cubed, so that's our 3rd row. 16 is 2 to the 4th, that's our 4th row. 32 is 2 to the 5th, our 5th row. 64, 2 to the 6th. 128 is 2 to the 7th, and 256 is 2 to the 8th. So if you look at this right here, that tells you the row number, and this is actually a massive calculator for 2 to the whatever power. So that's interesting. All right, so we're going to look at the patterns of Pascal triangle and just use these row numbers here in the binomial theorem. So let's just backtrack a little bit here, and we're going to expand these by hand. And this is just a plus b and a minus b raised to the 3rd power. So I'm going to expand those by hand so that you can see that if I use the 3rd row of Pascal's triangle, remember this is the 3rd row here, it seems like it would be the 4th, but the 1st row is the 0th row. If I used, so I'm going to circle this one right here. If I use this row in Pascal's triangle, it's going to match up to our final answer down here. So here we go. All right, so if I'm going to expand a plus b cubed, it would be a plus b times a plus b times a plus b. So I'm going to multiply it by itself 3 times. So I'm going to start off with multiplying these two together first, because we only multiply 2 at a time. So I'm going to bring down the first a plus b. And then to get the second one, it's going to multiply out as a squared plus 2ab plus b squared. How did I get that? So a times a is your a squared. A times b is ab. B times a is ab. You always want to put your variables in alphabetical order so you can see that they are like terms. So I have 2 ab's, so that's why this became 2 ab's. And then b times b is b squared. So then finally, I'm going to multiply the a all the way through and the b all the way through. So we get a to the 3rd, and that's from doing this. I'm going to multiply those together, and I get plus 2a squared b. Then we're going to multiply this together, and I get plus ab squared. Then we're going to multiply the b through, so I get b times a squared, and that gives me a squared b. So plus, and then we're going to multiply these together, so I get 2ab squared. So I'm going to line that up with its like term. And then finally, b times b squared is b cubed. So putting it all together, I'm going to add down. I get a cubed plus, I have 2 of these and 1 of these. So that gives me 3 a squared b's all together plus I have one of these and two of these. So that gives me 3ab squareds, and then finally plus b cubed. So my final expansion, when I multiply out a plus b cubed, is a cubed plus 3a squared b plus 3ab squared plus b cubed. I want you to notice, look at the coefficients. So the coefficients here, I'm going to run into my, here, let me move it up so I don't run into my taping stuff. There we go. So then if you look at the coefficients here, the coefficient here is 1. Isn't that the first number in the third row of Pascal's triangle? 1. Second coefficient is 3, 3. Third coefficient is 3, 3. And the last coefficient is 1, 1. Wow, that's awesome. We are in the third row of Pascal's triangle. We raise this binomial to the third power, and oddly enough, we get all the coefficients of the third row. There's another pattern that you'll see here in a minute, but I want to show you this one. They're very similar. So for this one, we're going to expand it out also. A minus b, a minus b, a minus b. Okay, so I'm going to start off by multiplying these two together first. So I'm going to bring down the first a minus b. And then the a minus b times a minus b is going to multiply as a squared minus 2ab's plus b squared. So be careful of your signs. So remember, this is a times a is where the a squared comes from. A times a negative b is a negative ab. Negative b times a is another negative ab. So that gives me 2 negative ab's altogether. And then a negative times a negative is a positive b squared. So now I'm going to distribute the a all the way through and the b all the way through. So I'm going to multiply the a all the way through, and I get a to the third minus 2a squared b plus ab squared. Then I'm going to distribute the negative b, so watch your signs, all the way through. So negative b times a squared is negative a squared b. Line it up with its like term. Then negative b times negative 2ab is a positive 2ab squared. And then a negative b times a positive b squared is a minus b cubed. Then put it all together, add down, a cubed. Negative 2 of these, negative 1 of those gives me negative 3 a squared b. And then 1 of these and 2 of those gives me a positive 3ab squared, and then minus b cubed. So you will notice that some things are similar between these two. So I had the third power. So we're still looking at the third row of Pascal's triangle. Notice that the coefficients here are 1, 3, 3, 1. The coefficients here are also 1, 3, 3, 1. These are identical. The only thing that's different between these two are the signs. So notice when the sign in the middle of the binomial is positive, every term will be positive. When the sign in the middle of the binomial is negative, these signs change. You always start with a positive, then change. Negative, positive, negative. So write yourself a note right here that with subtraction, the signs will alternate. So pause the video and write that down. The other thing that I want you to notice is look at the first term here is a, and the power is 3. Notice that we went a to the third power, and then notice that a decreases by 1 power as you go to the right. A squared, a to the first, a to the 0 would be 1. So notice that a is no longer there, because a to the 0 is 1. 1 times anything is whatever that thing is. Then start on the right side and notice that the right term here is b. So starting on the right side, raise to the third power. Notice that b is to the third power. This time we're going to go in the opposite direction. B is going to reduce by 1 exponent every time we go to the left. So b cubed, b squared, b to the first, b to the 0 is 1, so you don't see it there because 1 times a cubed is a cubed. Same thing happens over here. Your first term on the left is a, so start on the left. A is going to be raised to the third power. So a to the third, a to the second, a to the first, a to the 0. A to the 0 is 1. Then your second term is b to the third power. So start on the right side, b to the third, and go to the left. B squared, b to the first, b to the 0. That pattern is going to become important as we continue on further with Pascal's triangle, because I could have gone directly from here to here and not have to do any of this right there. Go directly from here to here, none of this here, right? So let's look at some more complicated problems and you'll see why Pascal's triangle is going to help us save us a lot of time. Okay, so for this particular page, I'm going to expand each of these a plus b's using the row from Pascal's triangle. So we're going to start off first, so you're going to have to refer to the previous page, but I'm going with these rows and I'm going to use the numbers in those rows as my coefficients. So in the 0th row, there's only one number, and that number is 1. And so remember that anything to the 0 power is 1. So this makes sense that a plus b to the 0 power should equal 1. That kind of looks weird. Let me see if I can erase that and not get that little curly Q on there. There we go. So I don't even have to use the pattern that I kind of described to you in examples 1 and 2. Then let's go to the first row of Pascal's triangle and raise a plus b to the first. Well, we know that a plus b to the first power should still be a plus b. But notice that the two coefficients, or the two numbers in row 1, are 1 and 1. And so then I'm going to take the left term, which is a, and I'm going to raise a to the first power, and then I'm going to go to the right and reduce it by 1. Well, if I go to the right here and reduce 1 by 1, I get a to the 0. A to the 0 is 1, so I'm not going to write it down. So then I'm going to start on the right side with b, and I'm going to raise it to the power that you see here, 1. And I'm going to go to the left and reduce b to the first by 1 exponent. That becomes b to the 0. And since there's addition in there, everything should be positive. So we still came up with a plus b. We've already squared this previously, but let's look at, since it's squared, we're going to look at the second row of Pascal's triangle. So the numbers that are in the second row are 1, 2, and 1. And so I'm going to take a on the left side and start here on the left. So we're going to take a, we're going to raise it to the second power. Why to the second power? Because the binomial is raised to the second power. And then I'm going to go to the right and reduce it by 1 each time. So this becomes a to the first, and this last one is a to the 0. I'm not going to write it because that's 1. Then we're going to start on the right-hand side with b over here, and we're going to raise b to the second power. Let me get a different color for b. We'll use pink. So b to the second, and then we're going to go to the left and reduce b to the second's exponent by 1 each time. So we would get b to the first, and then this would be b to the 0. So we're going to not write that because that's 1. And then because we have an addition sign, every term is positive. So notice that this is our factor pattern for a plus b squared. We get a squared plus 2ab plus b squared. Perfect. And then we just proved this in example 1 and 2, mostly example 1 because this is a plus. So if I take the third row of Pascal's triangle, I get 1, 3, 3, 1. And I'm going to start with a here, and I'm going to raise it to the third power. So a cubed, a to the second, a to the first, a to the 0. So let's write that in there. A cubed, starting on the left because it's the left term, a to the second, a to the first, and I'm not writing a to the 0. Then we're going to start on the right side and raise b to the third over here. You have to start all the way over on the right and then reduce it by 1. So I get b to the third, b to the second, b to the first, and then this is b to the 0. We don't write it. And because our middle sign is positive, every term is going to be positive. And that's what we got in example 1. So notice I'm not having to show any work. I just did it. Boom, done. So this work shouldn't take you too long today. You should be quite thankful for that. All right, so then we haven't done this one yet. So based upon everything that we've done so far, we're going to use the 4th row of Pascal's triangle. And I don't memorize these at all. I just write out Pascal's triangle and count the rows. So the 4th row is going to start with 1, then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and you end with 1. So we're going to start on the left side and raise a to the 4th. So start on the left, a to the 4th, and go all the way down. Okay, so a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and then we're not going to write a to the 0 here. So then we're going to start on the right side and raise b to the 4th all the way here on the right, and we're going to move in the opposite direction. So b to the 4th, b to the 3rd, b to the 2nd, b to the 1st, and then this, of course, is b to the 0. And then finally, all that's left is our signs. So there's a positive in the middle, so every sign is positive. And so you just squared out a plus b to the 4th power without any work. That's awesome. You get a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. So if you don't believe me, take a plus b to the 4th and expand it out. I personally would take a plus b squared times a plus b squared because you know that you get this, so you basically take this and multiply it by itself. So if you don't believe me, do that. All right, so example 4, let me go ahead and move this up a smidge, make it a little bit bigger. There we go. Okay, so this time we're going to raise it to the 8th power. So you're going to either have to, because I don't ever memorize Pascal's triangle, so you either need to look at your triangle, because you do have your notes with you, or I would just be writing out Pascal's triangle all the way to the 8th row. So I happen to know that the 8th row of Pascal's triangle is, so you might want to write yourself the following steps. So as I talk, I'm not going to write them down, but you can listen and write down the steps. So your first step should be to write down the coefficients or the numbers that are in row 8 of Pascal's triangle and leave spaces in between them. So that's step 1. Then step 2 is to start on the left side and take a and raise it to the 8th power and go to the right until you get to a to the 0. And then the third step is to start with b, raise it to the 8th power, and go to the left until you get to b to the 0. All right, so here we go. Step 1. Your numbers that are in the 8th row are 1, 8, 28, 56. I might run out of room. 56. And then we get 70. I should probably give myself a little bit more room. 70. And then 56. And then 28. I'm going to move down here. Well, maybe I'll go to the side. 28. And then 8. And then 1. Okay, so sorry, I'm doing a little bit of a curve here. So we're curving. Sorry about that, but there we go. All right, so then we're going to start with a and raise it to the 8th power here, and we're going to move to the right until we get down to here to a to the 0. Let me get my color. All right, so this is a to the 8th, because we're raising it to the 8th power, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the first, and of course this would be a to the 0. All right, and you should know whether you made a mistake or not as far as the number of these numbers in blue, because if you don't get to your a to the 0 and you run out of numbers or you have numbers left over, it means you chose the wrong row in Pascal's triangle, or you calculated the row wrong, something to that nature. So just be careful. And you should see symmetry when you calculate that row of Pascal's triangle. 1, 8, 28, 56, 70 is the middle term, then 56, 28, 8, and 1. All right, finally, we're going to start with b to the 8th on the right side because it's on the right. So we're going to start here and move it to the left until we get b to the 0. So let me get out my color. So b to the 8th, b to the 7th, b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st. And then of course our signs, we have a plus in the middle, they're all positive. Plus in the middle, and then plus. And of course you could rewrite that if you wanted to so that it's a lot neater, but there you go. We didn't have to show any work. I love this section. It's awesome and amazing. Okay, so what I would like you to do is go ahead and do examples 5, 6, and 7 on your own using what we've just learned. Wait on example 8. So I want you to pause the video, do 5, 6, and 7, and then restart the video and I'll give you the work, and then we'll do number 8 together. All right, so pause your video. Okay, so for number 5, the numbers in the 6th row of Pascal's triangle are 1, 6, 15, 20, 15, 6, and 1. And then you're going to start with x, raise it to the 6th power, and then x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and we don't write x to the 0. And then normally you would start with 1 and raise it to the 6th, but 1 raised to any power, 1 to the 6th, 1 to the 5th, 1 to the 4th, 1 to the 3rd, 1 to the 2nd, 1 to the 1st is all 1. So we really don't need to write that one in. And then your sign in the middle is positive, so all terms are positive. Simple, simple, love it, love it, love it. All right, then the next one uses these are so tiny I can hardly see them, the 4th row of Pascal's triangle, which the coefficients are 1, 4, 6, 4, and 1. So I'm going to start with x and raise it to the 4th power, x to the 4th, x to the 3rd, x squared, x to the 1st. And then again, 1, I don't have to raise to the 4th power and move all the way over because it's still going to be 1. But this one, hopefully you didn't get tripped up by this one. You've got a negative here. So the sign here is always positive. So then you alternate signs. So positive, negative, positive, negative, positive. So there you go. Make sure you double check those signs. All right, so then we're going to move to the 7th row of Pascal's triangle, which the coefficients are 1, 5, 10, 10, 5, and 1. So I'm going to start with x and raise it to the 5th power. And then x to the 4th, x to the 3rd, x to the 2nd, and x to the 1st. And of course, that's x to the 0. Then we're going to take 2 and raise it to the 5th. We're going to start here. So this one, you actually have to do a little bit more work. So 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st. And then your signs are all positive. So we're going to have a plus, 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 plus. Now you're not done because we actually have some multiplying to do. So we've got to multiply out 1 times 2 to the 5th, 5 times 2 to the 4th, 10 times 2 to the 3rd, etc. So our final answer is going to be x to the 5th plus, and then 5 times 2 is 10, so 10x to the 4th plus, and then 2 squared is 4, times 10 is 40, x to the 3rd. So sometimes some of these require a little bit extra work. 2 to the 3rd is 8 times 10, so that's 80, x to the 2nd. And then 2 to the 4th is 16, and then 16 times 5 is 80 again, so plus 80, x. And then 2 to the 5th, we should know, is 32. So here you go. So that one required a smidgy bit more work. All right, so now let's talk about 8. We move this up and give ourselves a little bit of room. The only thing about 8 that I want to caution you on is this 2x. The first term is 2x. It's only raised to the 3rd, so it's not so bad. So let's go ahead and walk through how we're going to show this one. You've got to be really careful. You have to use parentheses. So we're going to find the 3rd row of Pascal's triangle, which is 1, 3, and 1. So I'm spacing it out for a very good reason, so you need to also. And then we're going to start with our 2x. We're going to have to raise the 2 and the x to the 3rd power. So we have to raise both the 2 and the x, both of those to the 3rd power. So 2 to the 3rd and x to the 3rd. So it becomes 8x to the 3rd. So be careful. Don't just raise the x to the 3rd. The 2 has to get raised to that 3rd power as well. So then that means that this becomes 2x squared, and this becomes 2x. Whoa. I must have missed a term in there. 1, 3, oh, there's another 3. See how I knew I did something wrong? Whoopsie doopsies. All right, so let's erase this a little bit. And then I'm going to change this to a 3 and then a 1. So now I can do 2x to the 1st, and then of course this would be 2x to the 0. All right, so now I'm going to take 5, raise it to the 3rd, start here and work my way backwards. So times 5 to the 3rd, times 5 to the 3rd, times 5 to the 3rd. Oops. Clearly, I missed a step there. It should be 5 to the 2nd. I'm just trying to see if you guys are paying attention. And then, of course, this is 5 to the 0. We have a plus in the middle, so our signs should all be positive. And so this one is going to require a little bit more work on our part. So 2 to the 3rd is 8 times 1 is still 8. And then x to the 3rd is x to the 3rd plus 2 to the 2nd is 4. 4 times 5 is 20. And 20 times 3 is 60. So I get 60x squared. And then 5 squared is 25. Times 2 is 50. Times 3 is 150. So plus 150x. And then 5 to the 3rd is 125. And there you have it. So for these last two problems, you were only trying to find a specific term in the whole polynomial. So we only want the 3rd term of this expansion. So we're still going to go ahead and write it out, but we're not going to multiply everything out. We're only going to look specifically at the 3rd term and only multiply the stuff out for that term. So let's go ahead and go through our steps, and then I'll let you do number 10 on your own, and then I'll show you the work. So we're going to raise this to the 4th, but we're just not going to do all the work. So I need the 4th row of Pascal's triangle. So the 4th row of Pascal's triangle is 1, 4, 6, 4, and 1. And then we're going to take x and raise it to the 4th. We're going to start here. So we get x to the fourth, to the third, to the second, and to the first. And then we're going to take 3 and raise it to the fourth, but start from the right. So 3 to the fourth, 3 to the third, 3 to the second, and 3 to the first. And then don't forget your signs. We're going to alternate. The first term is always positive, so then negative, positive, negative, positive. Now we want only the, let's highlight it here, we want specifically the third term. So this is our first term, second term, this is our third term. So I want this term right here, so I included its sign. So I'm just going to multiply those things together. So 3 squared is 9. 9 times 6, 54. So our answer is 54 x squared. There's a very complicated formula that you could memorize, but why memorize when you can derive it? It really didn't take us that much time. All right, so I want you to pause the video, and I want you to do number 10, and then restart the video and check your work. Pause the video. Okay, here we go. So we're going to be using the 5th row in Pascal's triangle. And so you should have used the following coefficients for the 5th row. 1, 5, 10, 10, 5, and 1. And then you should have taken 3x. Well, I'm going to run out of room here, so I'm going to actually put everything down below. So 3x, and we're going to raise that whole thing to the 5th power. So I'm using parentheses. Then 3x to the 4th, then 3x to the 3rd, 3x to the 2nd, and 3x to the 1st. And then we're going to take the 2, and I'm going to put it below here. So 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and then to the 0. Now we are looking specifically for the 4th term. So our 4th term, is going to be, we have to figure out signs before we do that. So let's figure out signs. So the signs here is going to be a minus, plus, minus, plus, and a minus. So 4th term, 1, 2, 3, this will be your 4th term right here. And so if you multiply all that out, you should get 2 to the 3rd is 8 times 10 is 80. And then you get negative 80. Oh, wait, we forgot the 3. My bad. Okay, so we've got 8 times, and then 3 squared. So we've got this 3 squared, which is 9. 9 times 8 is 72 times 10. So it should be negative 720 x squared. Almost made a boo-boo. There you go. Pat yourself on the back if you did it. So good luck on your homework, and text me with any questions.